What's up, guys, and welcome back to another live stream from the Scalar Learning channel. And once again, today we are continuing with our push for ACT math. And today's going to be a little different from the last few days where I was blazing through a full practice test. And today's going to be a slower look. I know I've been getting some feedback. Hey, can you slow down? Can you? And again, that's the way my practice tests are structured, is that I'm going full throttle within the time limit. But today I'm going to peel it back a little bit and just go through 2 pages from this 5-pound Manhattan Prep ACT book, which is a great book, and topic by topic. I'm choosing trigonometry because I feel like that's where most of the questions are coming. And again, if people have suggestions and want to message me or leave a comment as to a different topic to tackle tomorrow or something else like that, I can definitely do that. I might even have something a little different for you guys tomorrow in terms of what I'm going to present. It might be sort of more of a last-minute study guide, you know, some tips, things like that. I'm kind of figuring out what I want to give you guys tomorrow that'll set you up best for Saturday. Okay, here we go. So no time limit here. We're just going to kind of nicely go through. And the good news is here, I'm going to keep an eye on the chat. Hey, what's up, Quang? I'm going to keep an eye on the chat. So if you guys have questions as we're working through, I'm going to try and answer them best I can. And I've got a good solid 40 minutes before my next appointment, so we can go at a nice pace. All right, so it says first in right triangle DEF, right? Here's a right triangle. They give us the right angle. Which of the following statements is true for angle D, which is right here, okay? So first they're saying cosine of, oh, by the way, they haven't given this side. So it's a right triangle. Yeah, I can use Pythagorean theorem, but if you know Pythagorean triples, this ends up being a 3, 4, 5 right triangle, just doubled. So instead of 5, the side is 10. So I always like those Pythagorean triples in the mix. Now it's saying cosine of D is 3 over 5. Well, what is cosine? Remember, with SOHCAHTOA, it's adjacent over hypotenuse. So what's adjacent to D? It's next to D, which is 6. So it's 6 over 10, which is not 3 over 4. It's 3 over 5. So this is out. Cosine of D is 4 over 3. We already know it's 3 over 5. And cosine and sine will never be greater than 1. So that's no good. Sine of D, it's 3 over 4. Okay, so opposite is 8. Hypotenuse is 10. So that's 8 over 10. This guy's 8 over 10, I should say, which is 4 over 5. That's also no good. And there's no other sign. So it's going to probably be one of these tangents. Tangent is the one that can be greater than 1. So this is actually possible. Let's look at E. So it says, or sorry, D. Tangent of D is opposite over adjacent, which is 8 over 6, which reduces to 4/3. And there's your answer. All right, here we go. Number 2. For a right triangle JKM shown below, which of the following expressions is equal to 1 over tangent of J? All right. First of all, I don't like how they did the... Well, no, actually, it's not bad. So the big ones are the angles. The little guys are the sides. So first of all, what is tangent of J? We should figure that out. Again, tangent is opposite over adjacent, which means it's J over M. And now they want 1 over this. Remember, we do 1 over something. It's just a reciprocal, which is M over J, and we're good to go. Okay, it's also cotangent, by the way. All right, next, and Quayne, let me know, or anybody else who's here, let me know if you guys have any questions, right? Okay, here we go. For right triangle ABC shown below, which of the following trigonometric measures is greater than 1? First of all, none of these can be greater than 1. It's got to be tangent, okay? But tangent of A is opposite over adjacent, 24 over 7, and that's that. In the following diagram, which of the following expressions gives the correct length of AC in this triangle? All right, so we want this is our unknown. So look, when I look at the trigonometric functions, again, I'll write SOHCAHTOA. All I'm trying to do to find that unknown is I'm trying to figure out, and we only have this angle. I mean, I could actually find this angle too if I want. Actually, let's do that. It's 71. But all I'm trying to think about is like, hey, what's an expression where I only have the variable is the unknown? Everything else is known. Well, what about sine? No, not sine. What about tangent? Tangent of that equals opposite over adjacent. So that's one option. Let's just start there. Tangent of 19 equals opposite over adjacent, which is 53. What's another thing? I could also do tangent of 71 equals opposite over adjacent. Now I have 2 expressions. I can solve for x and isolate. So, hey, in this case, x equals 53 tangent of 19, right? Because I multiply both sides by 53. 53 tangents right there. Okay, that's probably the answer. And then with this one, what I'd have to do is I'd have to multiply both sides by x and then divide by tan 71. So I'll do that in one step and just say 53 over tangent 71. I'm going to assume that's not there. That's close. That's close, and yeah, it's not there. So H is the only viable option. But these would be the two that would work. Okay. Number 5, diagram of a pool is below. The builder included the length of the pool in meters. Okay. The builder included the length of the pool in meters, which is this, but forgot to include the width, CD, which is the following expression gives the length. Okay, so again, we're trying to find this value. So what is a function I'm going to use? Since we don't have the hypotenuse, I'm going to use tangent once again. So tangent of 40, and this angle up here is going to be 90, 130, 50, right? 50, 40 is 90, plus 90 is 180. So I can say tangent of 40 equals opposite over adjacent. That's one expression. The other one is tangent of 50 equals opposite over adjacent, which is 25 over x. Okay, so what do I get from this one if I multiply both sides by 25? That's one option. Here, I'm going to multiply by x and divide by tangent 50. What's up, Vench? 25 over tangent of 50. So these are my two possible answers. This and this. Let's see which one's there. Nope. 25. Nope. 25. Nope. Nope. 25 tangent of 40. Boom. Done. All right. Number 6. In triangle DEF below, the lengths of the sides are given in inches with x between 0 and 3. Great. So that's the hypotenuse. What is cotangent of E in terms of x? Well, so first of all, I can find this inequality is just making sure we don't get some like crazy answer that's not possible. So I can use Pythagorean's theorem because I want to figure out what this is. Well, it's basically, remember, it's this squared plus this squared equals this squared. So I can do this squared. So here, let's actually write it out. Let's pretend this is a for now, okay? A squared plus x squared equals 3 squared, which is 9. So if I want to know what a is, subtract x squared from both sides, and then take the square root. So so a equals 9 minus x squared and square root. Okay, now I got to, so what's cotangent of E? Remember, tangent is opposite over adjacent. Cotangent is adjacent over opposite. So it's x over square root of 9 minus x squared. All right, now we go to number 7. A ramp must be built to reach a height of 5 feet, boom, with an incline of 18 degrees. Boom, what is the length of the ramp? AB in feet, AKA, this is my x value, right? All right, so again, which trigonometric function will use this side and that side? It's going to be sine either of that side. This side is, again, 72. These are complementary. So I could either say sine of 18 equals opposite 5 over hypotenuse, or I could say cosine of 72 equals adjacent over hypotenuse. Both are correct. So if I want to isolate here, I multiply by x divided by sine of 18. So one option is 5 over sine of 18 equals x. The other option is 5 over cosine of 72 equals x. This is another nice rule to remember, that cosine of 72 equals sine of 18, because sine and cosine, if they're complements, right, sine of 18, cosine of the complement will equal that, and vice versa. Anyway, so if 5 over sine of 18, boom, right there, 5 over cosine of 18. No, 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 no. All right. All right, use the following information to answer question 8. This is our final one, then I'll check it and see if we got any questions. In the figure below, ABCD is a square with a circle centered at E. A right triangle is inscribed inside of the circle. Its hypotenuse forms a diameter of the circle length C plus D. Okay. The lengths of the legs of the right triangle, A and B. Okay, whatever. So A is bigger than B. Great. Line segment connecting E and the right angle of the right triangle is of length E. Got it. These are radii, so these are going to be congruent. This is also going to be congruent. Which of the following statements correctly relates? Hey, what's up? Which of the following statements correctly relates the length of A, C, D, and E? A, C, D, and E. So C, E, and D are equal because they're all radii. C, D, and E are equal. This is the only one that says C, D, and E are equal. And I can see that A is bigger than all of them. And I think it said A is bigger than B. The fact that I know that A is... Hold on one second. I mean, I'm pretty sure that's it, but I want to know definitively. Oh, sorry. Did I circle the wrong one? I circled the wrong one. Sorry. C, E, and D are equal. It's this one. And I want to know that A is bigger than all of them. Obviously, they look bigger. It looks bigger, but hold on. Let's just make sure I can definitively state that a right triangle is inscribed in a circle. Its hypotenuse forms a diameter. So this is the leg. One leg, that's a second leg. And that's the hypotenuse, which is the diameter. And then these two are equal. No, I don't like to just say, hey, I can see it, and therefore, no. Okay, so it says A is bigger than B. Do I know that B is less than these two? That's the key. You see what I'm saying? It doesn't, yeah, see, B and B even looks smaller than these guys. So I'm trying to figure out that last part. It's got to be that, because that's the only one that's saying C and D and E are equal. C, E, and D. How do we know that A is bigger? A squared plus B squared equals that squared. And the hypotenuse is double. Do I know anything about the angles? And that's square. Like, I'm trying to think, is that a 30, 60, 90? So this angle is definitely bigger than that angle because A is bigger than B. I know that. Okay, I'm just gonna roll with J. Let me look at the answers. I know that J is right. I'm just trying to figure out why I can definitively say A is bigger than C. Yeah, I can't figure out a rationale. So let me get the answers and we'll go through and check, make sure. Okay, we'll just make sure I didn't make any mistakes, and then we'll also see that explanation. Okay, trigonometry. So this is 1 through 8. Okay, first let's just make sure I got them right. Yeah, it's definitely J. I agree with you, Quang. Like, it's gotta be because of the other pieces. I'm just like, how do we have enough information to know? Maybe they made a mistake. I don't know. This book is usually pretty good. Okay, so E F C H E, E F C H E, and then 6, 7, 8. J A J J A J. Let's see. Yeah, it's right. Okay, but let me just get their explanation. Number 8. A and B make up the lengths of the right triangle inside. Okay, this is represented by C plus D. Because the hypotenuse represents a straight line through the circle A and B, it must be the case that A plus B. So saying A plus B is greater than. So they're saying, got it. That's how you can tell. So this makes sense. Only contain shape. No. Michael definitely does not contain only shapes in trigonometry. I'm just choosing to focus on trigonometry because I feel like I've had a lot of questions on the trig problems that I've been doing. No, there's much more. There's a lot of algebra. So what they're saying is to know that the A part, they know that you can state that A plus B has to be greater than C plus D. Okay? And then they're saying that B and, no, wait a minute. B and D don't equal each other. Okay, hold on. And did they say anything else? They're saying that A is greater than B. And C is equal to D. Not sure if that makes any sense. So they're saying A plus B is greater than C plus D, which I agree with. Okay, that has to be the case. Any two sides of a triangle have to be greater than the third side. So A plus B is greater than C plus D, and then they're saying, and then A is the bigger side, got it. A is the larger side. Oh, I kind of get it now. I mean, this isn't exactly what they're saying, but since C and D are exactly equal to each other, you know what I'm saying? It's like an A is the bigger of the two. A has to be bigger than C. A has to be bigger than D, et cetera, et cetera. If B, B is not necessarily because B is the smaller, but if we know that A is the bigger of the two and these are equal, that's why. That's a tricky one. Just to like nail down that logic is tricky, but I think it was pretty. It's pretty straightforward in terms of like if you logic it out and figure it out like the way I did. What math level does the ACT go up to? So I mean, this is basically it. Trig is the highest. You can have some matrices sometimes, matrix multiplication. You can have some complex numbers and logarithms. I'd say those are the three. You could say most advanced concepts on the ACT. Yeah, if you've taken pre-calc, you're more than good. I mean, pre-calc is, even Algebra 2, you're probably pretty good, depending on your school's Algebra 2 program. That's probably all you need. I think pre-calc definitely, a lot of pre-calc goes well beyond this, And even if you think about conic sections, for example, conic sections don't even exist on here except for circles, and, parabolas, obviously. Oh, pre-algebra is very important on the ACT. Yeah, like if you guys have watched my live streams and the practice tests I've taken, or just look at the ones from ACT, you'll see pre-algebra is a huge topic. Pre-algebra and algebra are the biggest topics, I'd say. Very big topics. Yeah, pre-calc has log, but a lot of algebra 2 classes they'll cover logs. But yes, pre-algebra you definitely dive deeper, I'd say, into logarithms. Any other questions, guys? This is cool because it's actually fun right now for me in the sense because I'm not like trying to blaze through a test. I can actually talk to you guys a little bit more. So let me know if you have more questions before I got to go. With one, I think you should do, okay, you said, I think you should do like one live stream Q&A with college things and standardized tests. Sure. Oh, you mean like questions about college and stuff like that? Yeah, in pre-calc, you definitely have logarithms. Yeah. But like I said, also in algebra 2. Ooh, my connection is like really bad for some reason. All right, guys. I feel like the questions are kind of all right. Quang, I'll definitely try and set something up like that. It's a good suggestion. I'm gonna wrap it up today. This will be a shorter stream than I guess I thought, but it's all good. I hope it was helpful and useful, and I hope people watching later like it. And if you guys could give this video a like, that'd be awesome. And make sure to go ahead and subscribe as well. And what was I gonna say? Yeah, I'll tune back in tomorrow. I'm gonna try and post the time for my stream tomorrow as early as possible, so you guys know when it is. And it'll be sort of a last hurrah before Saturday to get you guys ready and primed to go. And what are the most important things in pre-calc for this? If you want to argue that circles are circles in the coordinate plane, know the circle formula. Which is x minus h squared plus y minus k squared equals r squared. Know logarithms, as I said. Know how to manipulate complex numbers, and know how to do matrix multiplication and matrix addition / subtraction. Those will pop up every so often, so you just want to have that process down. Just practice with like 5 or 10 matrix problems and you'll be good to go. Okay, guys, that is it. I will see you tomorrow.